Hello everyone. Good morning for people in Europe. I like to start this webinar about Huygens 2510, about what's new in the release that we released 2 weeks ago, I think. I hope you can all hear me and see my screen. So let's start. There are quite a lot of new things, so the developers in our team worked really hard. So you will be the witness of that very soon. First, in Huygens Professional, we made a start already in Huygens Essential, but in Huygens Professional, in Huygens Localizer, we improved the menu structure and added new icons to the taskbar. Also, the fonts we improved and we minimized that things are loading much quicker. Then if you look at the menu structure, you see under the different tabs, different functionalities. For example, under the quality control tool option, you see the quality control tool. You see that you can edit the microscopy parameters, perform a PSF distillation, etc. Then there is also a specific analysis and visualization tab with all the available options if they're in your license. And under the deconvolution and restoration menu, we've structured the options in such a way that it follows the image restoration workflow that is advised. Then for professional only, there is the option to customize the icon bar with many different other functionalities, which are sometimes also only available in professional. In Essential, we already had demo images on the right side in the main menu. These demo images can be used by users that are, for example, new to Huygens. There is a protocol with that, and this protocol describes how you need to treat the image, how you can treat the image, and the demo image is also opened directly in Huygens. So this is now also in professional then. Then for Mac users, we improved quite a lot. Previously, you needed to use Huygens on a Mac with an X server application, for example, XQuartz. That's no longer needed. Huygens runs natively on a Huygens on a Mac operating system. Then Mac OS 13, so Ventura is needed to run the Huygens 2510. You can now drag and drop images into the Huygens main menu. Some key bindings are more conventional for Mac, for the Mac operating system. Menus are at the top of the screen, and the Huygens dark and light mode, which could be activated under the preference menu, is now also according to the macOS setting. For the Huygens Object Analyzer, we've added in a later previous version AI segmentation. You're welcome to try this with a trial license. There has been some performance improvements implemented in this release. The thresholding that is default when you activate the Object Analyzer is initialized via the OTSU method. And the Huygens AI segmentation has now the option to save and load templates. And in these templates, you can load the segmentation settings and also the prompts that you use for AI segmentation. The result table of the Object Analyzer has also improved. So we produce now distances in microns instead of voxel coordinates. And also non-integer values are now reported in a scientific notation with 4 significant digits with units in the table headers, as you can see here. Then the Huygens Stitcher. It is already quite a complete wizard we are of course never satisfied, so we'll keep on improving the stitcher. But at this point, we think that you can do already a lot with the stitcher. You can do deconvolution, vignetting correction, stitching, of course, and now we've also added the option to stitch tiles of unequal sizes. We support 16-bit floating point data that decreases the need for computational resources. If you compare it to the previous 32-bit floating point data support, that increases also the speed of stitching, and it avoids scaling issues. So as you can see from the picture, especially from the XZ view at the top, we can deal with unequal sizes of tiles, both in X, Y, and in Z. And then last but not least, we support a pyramid file format. And in the wizard of the stitcher, this really has a big advantage because you can stitch data that doesn't fit in the RAM of your computer. That could already be done with a memory mapped file, but this facilitates it much better. So if the total image will not fit in the RAM, but just a few tiles will, you can still stitch this image. Then the image is saved as chunks on your disk. And this can be a terabyte dataset, as long as it fits on your storage disk. This image can then also be visualized on a computer with much less RAM capabilities, like for example your laptop, because it contains a pyramid file structure. And in this pyramid file structure, multi-resolution images are stored. And I will explain a bit more about that. So suppose that your image doesn't fit in your RAM. It's too large. And that happens lately with many images because the image sizes tend to increase and increase. So suppose you cannot load your image fully in RAM at the highest resolution. What we now can do with Huygens is store it as a pyramid file. That means you have multi-resolution layers in this image, and they contain different resolutions of your image, basically. Both low resolutions and high resolution data. And the higher resolution data is saved in chunks. So suppose now that you open a pyramid file in Huygens and you just look at the complete field of view, that may only require the loading of a low resolution version of the image in the pyramid file. Now, if you zoom in into a certain region, it may load a high resolution, but just a piece of the file, because you're just looking at just part of the image. And this allows then loading of much larger data than the RAM capabilities of your computer. So these pyramid files are saved in HDF5 or Huygens HDF5, and that has several benefits. It already existed, but now we made it possible for pyramid file structures. So it can handle pyramid files, multi-resolution structures. It can hold quite extensive metadata, and in our case this is very beneficial because we can store stat metadata, array disk metadata, light sheet data, etc. It can deal with 32-bit float. It can be compressed, the file, so it saves storage on your disk. It has open source viewers and is well supported by us. So what are now all the benefits of this pyramid file? I mentioned already that you can better visualize large data sets, and this can be data of hundreds to terabytes of data. And if you visualize, so here is the original data on the left. If you save this as a pyramid file, you just load it. You can visualize it at low resolution, complete field of view, and at high resolution if you zoom in. We can also load sub-resolution images from this pyramid file for 3D visualization in our different tools, in the surface renderer, in the SFP renderer, and in the MIP renderer. And how now can we generate such a resolution pyramid file? So we can generate this from an image in Huygens. If you have an image open in Huygens, here at the top right. Say it's 50 gigabytes large, so you need to have then a computer with enough RAM to load this image. You click on the icon Generate Pyramid at the top under the Tool menu, and this creates a window which says where you want to store the pyramid file. This pyramid file is then created, saved on disk, and also opened in the Huygens main window. So you need, in this case, still the RAM that is capable of handling the full dataset, because you generate the image in Huygens itself. A different approach is to load it directly from disk. Then you can load a much larger file. This file, if you go to the File menu, you say Generate Resolution Pyramid, then it opens this window. Here you select where the original image is located and where you want to store the pyramid file. So this data, 50 gigabytes for example, or hundreds of terabytes of data uncompressed, can be on disk. You generate the pyramid file on the fly, it's saved also on disk, and it's opened in Huygens. So you don't need then the RAM of your computer to be fitted to the RAM of your original dataset. Now there are some limitations to this pyramid file. You can view it, but analysis, that is still not possible at this point. We are further developing the functionalities of the pyramid file structure in Huygens. At this moment you can extract images from the pyramid file. So if you have the pyramid file open in Huygens and you right click, you have here the option Extract Image. And also in the icon bar menu you have the option Extract Image. And this pops up a window in which you have an overview of all the different resolution images in the pyramid file. And according to what you have available in your computer as RAM, in this case we opened this on a server of 3 terabyte with even 3 terabytes of virtual memory, so there's 6 terabyte available, so that's of course quite a lot. But you can also, for example, do this on your laptop and select a sub-resolution level that meets your RAM capabilities. So then you can extract the image again, and this full resolution or sub-resolution image, you can work with that and analyze it. Now, how to get access to this pyramid file structure? I already mentioned that it's available only in professional. Users who have already an essential license have the option to upgrade to professional, and then only we count for the price difference if they're under a valid maintenance contract. Some other additional advantages of Huygens Professional are, besides the resolution pyramid file format, that it has a Python and TCL/TK shell, so you can run from the command line and you can run scripts. It has also links to different Python libraries. There are many different arithmetic functions in the operation window, and you can also visualize your theoretical points-spread function of your specific image and have like a quality assessment as compared to your experimental PSF, for example. Then going away from the pyramid file and to our improvements in Huygens 2510, we improved the hot and cold pixel remover. Hot pixels, they are very common, cold pixels a bit less. Hot pixels can be really troublesome. They distort your image. You see here these white dots. These are typical high intensity values of pixels, very local. They are often conserved in the Z dimension, as you can see here in this XC slice. And they're even existing often in the different channels, giving you false co-localization results. So it's very important to get these fixed. So we can do that with our hot and cold pixel remover. That tool has been improved quite a lot. So what What did we improve? We reduced the memory requirements for this tool. The optimal sensitivity of detecting hot pixels is set automatically when you open the window. There is a table now with both hot and cold pixels here at the bottom left for each channel. Then we offer support for a combined hot and cold pixel correction. You can do that here on the right bottom. You can click on both hot and cold pixels that are corrected. And you can also load a region of interest or specify region of interest, and then the estimation of the hot pixels is only done on that specific part of the image, and that reduces computational time. If you have, for example, very large images, this can be helpful. And then the result is here. This is an image that has been corrected for hot pixels. So on the left, you see the hot and cold pixels, in white. In white because they exist in both channels. And on the right, you see that this has been corrected with this specific tool. And then last but not least, support for the Aurochs spinning disk. Aurochs acquisition software has now a button which says send to Huygens. So from the acquisition or from a file opened in the acquisition software of Aurochs, you can send a file directly to Huygens. This opens Deconvolution Express. It parses automatically the microscopy metadata, so that is correct. And then you can start deconvolution immediately. And it will not surprise you, hopefully, that this gives an improvement of the data. So on the right, an Aurochs spinning disk raw dataset, and on the left, I should say, and on the right, the deconvolved version. You see, especially in the Z direction, the improvement is significant. Here, there's just a zoom of an area of this image, raw and deconvolved. And if we make a line plot, you clearly see that the red is raw and the green is deconvolved, and that shows a significant improvement in contrast and in signal. So if you're interested in more, you can watch this webinar again. We record it and we post this online, probably tomorrow. Have a look at our webinar series about mastering co-localization analysis. That will be this month and the next month. There will be 3 sessions. You can test the latest version. Just drop us an email or fill out the request form online, svi.nl license request. And if you have any questions, please post them in the chat or just unmute yourself or raise your hand. That's maybe better to get it organized. And then we so there is a question about the pyramid file format. The file does not open in Fiji, but you can. There are existing open source viewers for HDF5, so you can look into the file structure. This format is at this moment not supported by bioformats. What is supported is ICS2, but that does not have the pyramid file structure yet, unfortunately. So we keep on developing, of course, but at this moment, the Huygens pyramid file structure is probably not, you can probably not open that in Fiji. Yeah, this is a constant struggle. I can explain a bit more on that maybe, also because the developments in the file formats, also OMI-ZAR, they're still limited in containing the metadata that we produce or that we read from image files like STAT, light sheet, and array detector data. And we want to conserve that metadata, so we need to be able to do that. The community is not that far yet doing that. We are in communication with them. And that's why we decided to take a leap and develop this format. And that is as open as it can be at this moment. Okay, if there are no further questions, then I will end the session. There is another session this afternoon. You're also welcome to attend that. and else you can watch the recording or just test it yourself. Get a test license. Thank you very much for your attendance.